Good evening, dear all. Today we shall do some numericals on Gauss's law. Now, the most important numericals of Gauss's law are with the cubes. Either they are placed individually or they are placed on some axis. So, both of these varieties we will begin with. Okay, so now let us do the first question, which is the application of Gauss's law to the cube. Now calculate the electric flux through each of the surfaces. Okay, so if we have the cube, it will have 6 surfaces of a closed cube of the length L. If a charge Q is placed at its center. Now very important, whenever a cube question is given, you have to understand where is the charge placed. The first case is, there are 4 cases. If it is not kept on axis, we will talk about all the 4 cases, though here the numerical is only about 2 cases. So, right now let us talk about the case 1, in which the charge Q is kept at the center of the cube. And they are asking us to find out the flux through each face. How many faces the cube has? 6 faces. So through each of the phase, how much flux is coming up? That is what is the question. That is the bit number 1. So let us talk about the bit number 1. What is it? Where is the charge? Charge Q is at the center of the cube. That is the first part of the question. I have placed it also at the center of the cube, as you can see. Fine. Okay. So, what is the first thing we have to see for Gauss's law? That the charge should be within an enclosed surface. Is it within an enclosed surface? Yes. Which surface? A cube. So, then we have to just count the number of surfaces and divide the total flux. So, what is the total flux? Phi is equal to Q net, that is Q in this case, divided by epsilon naught. This is the normal Gauss's law. So which is equal to Q upon epsilon naught. This is the flux which is kept at the center. Now they are asking to each surface. So phi for each surface. How many surfaces are there? 6. So we have to divide phi by 6. This is phi divided by 6. So what answer do we have? Q epsilon naught into 6. 1/6 of Q epsilon naught. This is the flux formula for the charge kept at the center. There are 6 surfaces. So flux for each surface is 1/6. I can write phi net here. So phi net upon 6. So this is our first bit answer. We are done. Just like the cube in my hand, you should be very clear with the question whether they are asking the flux through the whole cube or they are asking through each surface. There are 6 surfaces, so divide the total flux by 6. I hope you have understood this concept. I am just moving. You can take a pic of it. Fine. Now let us go to the next part of the question, where they have placed the charge Q at the corner or vertex of the cube. Okay. So if this is the question where we have placed a charge at the vertex of the cube, then to use the Gauss's law, we have to cover this charge Q in an enclosed surface, only then we can use the Gauss's law. So to cover it, we have to place various cubes around the original cube. This is our original cube. Okay, so first let us understand here, then we will go to the diagram which is seen here. This is our original cube which we are considering, and here I have placed a charge cube which is at the vertex. I can place it at any vertex, but I have placed it here. Now to cover this charge here at the vertex, I need to place one cube here, one cube behind, one cube this side. So how many cubes do I have? Have I placed? 3. Then one above this 4, one above this 5, and then in the gap at the edge I have to place 2 more cubes. Okay, so total how many cubes I have placed? 7. 1, 2, 3, 4, 5, 6, 7. And this original one is the 8 cube. Fine. Now we will see how to arrange it in the format which I have shown. Okay, so now as I said, I will bring the red color cube. This is cube number 1. Very important to number the cubes. Remember the cube. So that is the answer. Okay. Then in the side I have placed one more. Above that I have placed one more. So 3 I have done with. Then the fourth one I am placing behind the original cube. Okay. Then the fifth one I am placing above the one which I have kept behind the yellow one. The yellow one is looking here, and above that yellow one I have kept one more. Now there is a gap. As you can see, there is a gap here, edge here. Okay, there I will place first the blue one. And below that I will place the second blue one. Okay, fine. So now I am ready with the placing of all these 7 cubes around the charge cube which was placed at the corner. Let us just see, this red one was the top one. This green one which is seen here, that is behind side. Then above it one more green, and this yellow one is behind, above it another yellow one, and in the gap there is a blue one and there is another blue one. Clear? Okay, so there are total 7 plus 1, 8 cubes which have covered the charge cube. So the flux which is equally divided in all the 8 cubes is phi is equal to q. There is only one charge q enclosed, so q upon 8 epsilon naught. This is for the total cube, the total flux through this arrangement. 8 cubes, flux is divided equally through all the 8 cubes. So our flux is q upon 8 epsilon naught. You can also read it as 1 upon 8 times q upon epsilon naught, which is our Gauss's law's formula. Now let us see the second part where they have asked us to find out flux through every surface. Okay, now we have to see flux through every surface. Is it there? Is it not there? When it will not be there? Only if the angle between E and delta S is 90, there will be no flux. If the angle between E and delta S is 0, there will be maximum flux. If it is some theta, then according to the theta, the flux will be there. So we have to see now through how many surfaces the flux will not be there, or through how many surfaces the flux will be there. Now for that, let us consider our original cube. This white color one was our original cube. Out of that, This portion there is no cube kept. Front portion there is no cube kept. And the lower portion also there is no cube we have kept. This portion, and the front portion there we haven't kept any cube. Okay. The behind three portions you can see this one is attached to one cube. This 2 is attached to another cube. Behind these two, there is one more behind this face. There is one attached cube, two attached cubes on the top. So, all these three faces, above and below, the flux for this cube will not be there because you can see, as you can see, okay. For all the three cases, this is the direction of E. Direction of E is perpendicular to delta S. Okay, if this is the direction of E, then this is the direction of S. You can see, this is the direction of S and this is the direction of E. In this case also, this is the direction of E and this is the direction of delta S. So, in all the three cases, this one, the above one and the behind one, E top delta S has an angle of 90 degrees. Okay, so cos 90 is 0. Correct? So flux will not be there through these three edges or through these three surfaces. In all the three surfaces, E and delta S makes an angle of 90 degrees. So flux will not be there. What about the other three surfaces as I showed? This side ones, 1, 2 and 3 is behind. So who are the others? 4, below 5. Yes, and in the front 6th one. Every cube will have 6 surfaces. This I am talking about only this cube. Okay. So 3 surfaces flux will be there. Why? Because the angle between all these 3 surfaces will, the angle between all the 3 surfaces will have E and delta S theta is equal to 0 degree or some flux will be there. Is it clear? Okay. So the angle is not 90 in all these 3 surfaces where I have put the slashes. Fine. Okay. So flux will be there. So the same story will follow for the other 7 cubes also. So finally, phi for each surface is equal to 1 upon 3. 3 surfaces will have, I can write 3 here also. 1 upon 3 multiplied by 1 upon 8 q upon epsilon naught. So 1 upon 24 q upon epsilon naught is the flux through each surface of the cube arranged, provided the charge is placed at the corner or the vertex of the original cube. The others we have arranged such that we make a closed surface. Okay, because there were 8 cubes, the charge through each cube is 1 upon 8 q upon epsilon naught. Because there were only 3 surfaces through which the flux is there, we have divided the flux for the cube on 3. Because only 3 surfaces will have, the other 3 won't have. So 1 upon 3, 1 upon 8 q upon epsilon naught. So what is my answer? 1 upon 24 q upon epsilon naught. So remember, whether they are asking through the cube and whether they are asking through each surface when the charge is placed at the corner. Okay. This is the case number 2. First case was charge was placed at the center. Second case is charge is placed at the corner or the vertex. Let us go to the third case. These are all JEE NEET questions asked last year and this year. You go and you check. This you have to remember, but I am explaining so that you understand it with logic and remember. Now I have placed the charge at the center of one of the face. So this is again I have drawn one cube and placed the charge at the center of one of the face. So I have to cover it now. So how do I cover it? By another cube. This charge q is in the enclosed surface. Very happily. Fine. Okay. So now what is the total flux here? I have used two cubes. So with the same rule, I will write q upon 2 epsilon naught. This is the flux through the cube. Overall cube. Okay, I have used 2, so this flux will distribute in 2 cubes. Now through surface, what should I do? What is seen here? This portion has 2 surfaces in it. Correct? And in both these surfaces, E and delta S has an angle of 90 degrees in between. Agreed? Okay, you can see here. Both can go like this also. Okay, the face is also like this and electric field is also like this. So the surface will have an area element of perpendicular. So E is like this or like this, but delta S is perpendicular. So what is the angle between E and delta S? 90, cos 90. Cos 90 is 0. So these 2 surfaces which are there in the between will not have a flux. So how many are left out for this cube now? One surface is here for this cube, one surface is here for this cube. So how many are left out for this? 5. And how many are left out for this? Another 5. So total 10. I can write it as 5 surface flux. Flux for 5 surfaces is equal to q upon 2 epsilon naught. So for each surface how much? Overall each surface how much? Q upon 2 epsilon naught multiplied by 1 upon 5. From where did I get this 1 upon 5? Because I can see here 5 surfaces. That side also 5. So what is my answer? 5 for each surface. In this case, when the charge is kept at the center of one of the surface, my answer is q upon 10 epsilon naught. Done? Okay, there are open 5 surfaces inside, 5 surfaces that side, total 10. That way also you can find out. Okay, this is for 1, 5 for 1, multiplied by 2 cubes. So 10 for 2 cubes. Done? So this is for the cube and this answer is for the surface of the flux. Each surface will have this much. And in the central portion, as I explained, there is no flux because the angle is 90 degrees between E and delta S. Fine. So I just move, you can take it. Okay. Now let us go to another category where we have placed a charge at center of an edge. So this is the charge which we have placed at the center of the edge. Which edge we have used? We have used this edge. Okay, we can place it at any edge, but this edge I have placed one charge. Now I have to cover up this charge using cubes. So I have made one arrangement to make it easier so that we can cover up this charge. Let us see how do we do it. Okay, so let us see. Here I have lifted one cube, placed it here. I have lifted one cube, placed it in the side, one at the top, another one at the side, and now you can see one gap there. So to fill that gap and cover up the charge from up towards this side, I have placed one more cube. So now as you can see, this charge Q is covered by 3 more cubes. So totally how many cubes we have used? 3 plus 1. Let us number them. 1, the first one, the original one. Then we placed 2, the second one. Then we placed 3, the third one. And then we placed the fourth one in the gap. So we have total 4 cubes which helped us to cover the charge placed at the center of the edge of one of the cubes. So what is the flux of that cube? Cube's flux, how much? Because we used 4 cubes, we will write it as Q upon 4 epsilon naught. Agreed, because we have used 4 cubes. Done. Now, we want to know the flux through the surface. So, we have to check out which are those surfaces through which the flux link is there. We have to check out that. Okay. So, we go back to the original cube and check out in that cube, and then we will apply it to the other cubes. Okay. Now, you can see this surface as the electric field from the charge radially outwards. This is electric field. So this electric field direction is parallel to this surface for this cube. Cube number 1. Electric field for this surface from the charge is also parallel to this surface. So, electric field is parallel to surface 1 and surface 2 of one of the cube. So, through both these surfaces, the flux will be 0 because the angle between the electric field and the area element will be 90 degree. So, cos 90 is 0. So, the flux will be 0. Correct? So, flux through this surface and this surface will be 0. Now, how many other surfaces are left out for this cube? 4. So, only through these 2 surfaces the flux will be 0. The other 4 surfaces of the cube will have a non-zero flux. Agreed? So, what should we do? We should say that 4 surface will have flux. How much? Q upon 4 epsilon naught each. So, flux through each surface or one surface is equal to 1 upon 4. This 4 I have brought down. Q upon 4 epsilon naught. So, what is my answer for flux through each surface? 1 or Q upon 16 epsilon naught. Fine. So, this is the flux through each surface. This is the flux through the cube, provided the charge is placed at the center of one of the edge. Fine. Okay. So now I will just move and you take a screenshot of this portion where the charge is placed at the center of one of the edge of the cube. Fine. Place the cube on the axis. Such numericals also can come in all the inferences. Okay. So now let us see that kind of a numerical. The electric field components in the figure are, this is the electric field given to you. It is given E with subscript X. It means electric field is only along the X-axis. Along Y-axis, along Z-axis, it is given that the electric field is 0. And one particular number is given with a constant whose value alpha is 800 Newton per centimeter square. At present, don't worry about the value alpha. Okay. Calculate the flux through the cube. That is the first part of the question. Second part of the question, charge within the cube. Okay. So, first part of the question, calculate the flux. Then we will go to the charge within the cube. Now, here, what is given to us? That the electric field is along the x-axis and one particular cube is placed on the x-axis, and the distance between this face of the cube and the z-axis or the y-axis is A, and this is also the length of each face or the side of the cube is also A. Fine? Okay. So this is the information given to us in this numerical. So now we have to find out the flux through this particular cube. Now let us see through how many faces does actually the flux is available to us. Let us name these faces as face number 1 and face number 2. The rest of the faces, as you can see in the cube, if I place this cube here, this is our face number 1, this is our face number 2. The rest of the faces, that is up, behind, front and down, all the faces, the direction of the electric field is perpendicular to the direction of the area element. So theta is equal to 90 degrees in all the other faces except phase 1 and phase 2. I hope I am clear. How? That I have already taught, but once again you can see the direction of S in this upper surface. Delta S also you can write, and direction of E, which is already given to us. You see the angle between them is 90. Here also the same thing. This is delta S. What is the angle between delta S and E? Or you can even see this surface also. Fine. So that is also 90. Theta here is also 90. Same thing for the front face and the behind face. The direction of the front face will be like this and the behind face will be like this. So the angle between E and delta S for all the faces which I showed just now, that is the front one, the behind one, the upper one and the lower one, all have theta is equal to 90. So which two faces are left over? Only the side two faces. Now we have to determine the angle for the side two faces. Let us go to the face number 1. What is the direction of delta S in this case? Outwards, perpendicular to the surface. That is our rule. For the direction of the area element, I have drawn. Okay, but the electric field is along the positive x-axis. So what is theta in this case? You can see anti-parallel they are to each other. So theta in this case is 180. Let us name it as theta 1 for phase 1. Theta 2 for phase 2. What is the direction of delta S in this case? Okay. What is the direction for delta S in this case? Outward. So what is theta? Theta 2 is equal to 0 degree. Same direction. So these two phases only the flux will be available to us. So let us calculate the flux phi 1 and phi 2 and we shall add it. Okay. So what is our phi? Phi is equal to phi 1 plus phi 2. So let us first find out phi 1, which is equal to E1 dot delta S1. I have written 1 1 so that we understand that the flux is for the phase 1. Okay. So what is E1 delta S1 and what is the angle between them? As already done, cos theta 1 What is it? E1 delta S1 cos theta 1 is 180 degrees. Cos 180 degrees. So what is my answer here? E1 delta S1 cos 180 degrees negative 1. So I'll write it as negative. So my phi 1 is equal to negative negative E1 delta S1. Similarly, let me put this as equation number 1. Let me find out phi 2. Phi 2 is equal to E2 dot delta S2. Though the values of E1 and E2 are same, delta S1 and delta S2 also are same. Just I am naming it to make you understand that this is for the phase 2 where the flux is non-zero. Fine? Which is equal to E2 delta S2 cos theta 2. What is my cos theta 2? 0. So E1, E2 delta S2 cos 0 is 1. So what is my phi 2? Positive E2 delta S2 cos 0 is 1. Let me name this as equation number 2. So what is my phi 1 plus phi 2? Phi 1 and phi 2 are ready with me. Now according to the given expression for the electric field, let us first find out E1. What is E1? Alpha x raised to half. Now what is this x? X is the distance between phase 1 and the origin. Okay. So what is the distance? That is a. So what is my answer? Alpha a raised to half. Okay. Now E2. Again I go to the expression. Okay. Here what have I used? I have used x is equal to a. Alpha again x raised to half. But for the phase 2. So what is alpha for what is x for the phase 2? This much a and this much a. So 2a. Till I reach the phase 2, the distance between the origin and the phase 2 is a plus a, 2a. Fine. So what is my answer? 2a raised to half. What have I used x here? X is equal to 2a. So I am ready with E1 and E2 also. Fine. Delta S1 and delta S2 for the faces of a cube which is equal to a square. That also I am ready. Correct? So I have to just substitute now to find out both the values. Fine. Okay. So now what I do? I just club all this together, reduce it and place it here. Okay. So now I am ready to use this data and reuse the board also. Fine. Okay. So I am ready here to find out phi 1 and phi 2. Okay. So I will first find out phi 1 is equal to negative E1. What is my E1? Alpha a raised to half. Okay. And delta S1 as I said is a square. So my phi 1 is equal to negative alpha a raised to phi by 2. Similarly, phi 2. What is phi 2? Positive alpha 2a raised to half into delta S2 which is a square. So my answer becomes alpha 2 raised to half is root 2, a raised to half plus a multiplied by a raised to 2 is a raised to phi by 2. So phi 1 and phi 2 are ready with me. Okay. So finally I add to get the total flux. Phi is equal to phi 1 plus phi 2. What is it? What is my phi 1? Negative alpha a raised to phi by 2. What is my phi 2? alpha root 2 a raised to 5 by 2. So finally 5 is equal to alpha taking common, a raised to 5 by 2 taking common, we have root 2 minus 1. This is the flux which we have. Now we can substitute in this 5 is equal to alpha. Alpha is given to us as 800. Okay. And A is also given to us as 0.1 raised to 5 by 2. Substituting that value which is given to us. Okay. Alpha is given here. A is given there. We get the value as 1.05 Newton meter square per Coulomb square. Okay, this is what we get for the flux. There is one more part of this question. Okay, that is we have to find out the value of charge. For this again we go back to the Gauss's law, in which flux phi is equal to Q upon epsilon naught. So Q is equal to phi into epsilon naught. What is my phi? My phi just now we got is 1.05 multiplied by epsilon naught. What is it? 8.854 into 10 raised to minus 12. Okay, coulombs, because it is charge. These two units will cancel and we'll get coulombs. Charge is R. So that is equal to 9.27 into 10 raised to minus 12 coulombs. Fine. Okay, so Q is equal to that. So this is what is asked with us in the question. So the same kind of question can also be asked when this particular cube is placed at the origin. Okay, so going back to the same numerical, instead of this cube placed here in the previous question, now it is placed here at the axis origin. So what will be the situation? Everything will be same except that when we write E1 is equal to alpha x raised to half, here we have to substitute x is equal to 0. Why? Because it is on the origin. Correct? So this answer becomes 0. Even is not there. So the flux will be only through one of the surface, that is the surface 2. Through surface 1, the distance is 0, x is 0. So the flux will be only through the surface 2.